So in 7th grade, we have this strategy called combining like terms. And what combining like terms helps us to do is to simplify, or if you will, write in a shorter form, algebra expressions. And an expression is like just a whole bunch of things thrown together. Not an equation, an expression. Okay? So it helps us to simplify algebra expressions. And sorry, my handwriting is not good today. So like terms can be identified two different ways. When you're talking about algebra tiles or in visuals, they have the same shape and the same size. Think like how with fractions you need a common denominator in order to add things. That is actually the same idea as combining like terms, because when you add fractions, you have to add thirds to thirds because they're the same shape and the same size. In algebra, they have the same variable and they also have the same exponent. So an example of like terms would be, say, 3x and 7x. If you had 9x squared, that would be like terms with 3x squared. Now they can be negative too, so you could have negative 2x and you could have 5x. Those are like terms. Things that are not like terms. So things that are not like terms would be 3x squared and 2x. Even though they both have x's, one of them's a squared and one of them isn't, so they are not like terms. Let's say you have a negative 9 and 4x. Since the negative 9 does not have an x, not a like term. Let's say we have 4x and 5y. One of them is an x, one of them's a y. Can't put them together, like apples and oranges. So those are not like terms. Algebra tiles are something that we use to help people visualize these like terms and get that whole idea of the same shape and same size thing. And so we have three different algebra tiles. We've got this x squared tile, which is a square. We have an x, which is a rectangle, and we have our unit square right here. And algebra tiles are named for their area. So they are named for their area. So this x squared tile is called x squared because it is x by x, and x times x is x squared. This rectangle one has the same height as that square, and so that is x high, 1 wide, and notice how its width lines up with the width of the unit square, so the unit square is 1 by 1. So this collection of tiles that's in front of you would in algebra be written this way: 1x squared plus 1x plus 1. Now, just to let you know, this one and this one do not have to be there. I like to put them there because it reminds me that x squared means I have 1x squared, and x means I have 1x. But that is considered simplified because you cannot put those things together, because you can't add an x squared with an x because they're different sizes, different shapes. Can't add an x to a 1 because they're different shapes, different sizes. So let's look at what we can put together on the next slide. So if I have this example, first thing you want to do is identify your like terms. A lot of people like to circle them, box them in, that kind of thing. So I have a 3x squared. I do not have any other x squareds. I have 5x and I have an x. Then I have a 4 and then I have a 3. If you were to draw that, you would have 3x squares. You would have 5x rectangles. You would have 4 unit squares. But then you would also have another x rectangle, and then you would have 3 more unit squares. So essentially what happens is you group these things according to what they have alike. So 3x squared doesn't get grouped with anything else, so that's just 3x squared. But then all these rectangles can get grouped together. So in algebra you could write that as 5x plus x, and that's 6x. Then we have these 4 unit tiles, 4 unit tiles and 3 unit tiles, and so they become 7. So now my final answer is 3x squared plus 6x plus 7. So even though that answer looks like it's not done, it is, because we cannot join any more of those things together, so we have written it in the shortest way possible. Another way you can look at it is, since we don't know what x is, we could not figure out what this equals, because all of these multiplications and exponents would have to come before the addition. So essentially, we're stuck, and we're done. So that's it. So this problem is the same idea, but because there's minus signs, that kind of throws people off a little bit. But here's the good part. You can use what you know about integers, and you know that subtracting a positive is the same as adding a negative. You know that that is true, and so that's going to help you out, because then what you can do is you can rewrite this problem as 2x squared plus negative 4x plus 5 plus 4x squared plus negative 3. And that way you can move things around okay, and you don't have to worry about the negatives so much. So let me look at what my like terms are. I have 2x squared and 4x squared. Then I have negative 4x. I don't have anything else that just has an x with it. And then I have 5 and negative 3. Now if you want to draw this, it would look like this. Those of you who are visual and like to draw these, you would have 2x squareds. You would have 4x rectangles, but they're negative. So then you could label them with a negative sign. Then you have 5 unit squares, 2, 3, 4, 5. My highlighter thing's really fat, so it makes these look big. And then I've got 4x squared, 1, 2, 3, 4, and then I've got 3 negative unit squares. So when I put my things together here, I have, so let me erase the drawing for right now, just so I have some room. Or maybe I'll do this. Hang on. Let me move this up. There we go. So what I sometimes do with algebra is I'll rewrite the like terms together. 2x squared plus 4x squared, which would be the same as if I were to like take these and kind of put them together. And then I have my negative 4x, and then I have my 5 units, and then I've got negative 3 units. So now I've got my like terms grouped together, so now I can simplify these, which means I can just kind of simplify each group. So I've got 2x squared and 4x squared. 2 plus 4, 6, so I have 6x squareds. Notice how the 6 does not get squared. The 6 tells you how many squares you have. Then I have negative 4x, And then 5 plus negative 3 is positive 2. This is my final answer because that represents all this stuff in the shortest way possible. As if combining like terms wouldn't be confusing enough, sometimes they like to throw in distributive property into these problems to make them a little bit more complicated, but it just adds an extra step. So let's refresh our memory on what distributive property really means. Distributive property means if I have a number in front, say 4, and I have stuff on the inside of parentheses like x plus 3. Distributive property says I'm going to take 4 times each of those things because I'm distributing that 4 out to each thing in the parentheses. So that would be 4 times x plus 4 times 3, which is essentially 4x plus 12. So just a little fresher on what distributive property means. Sometimes you'll see these in addition to combining like terms. For example, let's say I have a problem like, let's use that 4 times x plus 3, but then there's also a 5 times, let's say, 2x plus 7. Okay, so if I have this problem, because multiplication is before addition, I'm going to do the distributive property first, which means I'm going to do the 4 and then I'm going to do the 5. We already did the 4 off to the side, and we know that that's 4x plus 12. But to show the 5 getting distributed, I've got 5 times 2x, and I've got 5 times 7. When you do 5 times 2x, basically you just group the 5 and the 2 because those we know, and then stick the x on it. So 5 times 2x is 10x. 5 times 7 we know is 35. So I've done the distributive property, but if my directions say to simplify, that means to write in the shortest way possible, and I'm actually only halfway there. And the reason I'm halfway there and I'm not done is because I have like terms. I've got 4x and I've got 10x, and then I've got 12 and I've got 35. So let's put our like terms together. So I have 4x plus 10x, and that is 14x, and then I have 12 plus 35, and that is 47. So my final answer is 14x plus 47. So just be aware that sometimes they like to increase the difficulty by throwing distributive property in there. Just makes an extra step.